Hi guys. So welcome to the another podcast. So today we have with us Mr. Gaurav Avasthi sir, who is working as a sustainability and a climate change consultant for different MNCs. So without wasting any time, let's start with this podcast. Hi Gaurav sir, how are you?
I'm good, thank you.
Yeah. So first of all, thank you so much, sir. We know that there is a huge time difference, but still you have taken out the time to be on the podcast with us. So, sir, please tell audience something about yourself. I think that the audience would love to know that.
Sure. Yeah, I mean, as of today, I'll start probably in the reverse chronological order. As of today, I work as you mentioned, as a climate change consultant uh, with with the industry advisory group of Tata Consultancy Services (TCS).
Okay.
Uh, and although my larger, I have around 22 years of working experience, and most of my career has been in the technology side of things, mostly as an enterprise architect or a solution architect. For the last 2014 onwards, I've been working in more or less in IoT, Internet of Things. And in fact, Kaushal and I started some initiatives together way back in India in 2013, I guess. Um, and I think in the last 3 years, three and a half years, I have kind of pivoted towards using technology more for the larger good,
Mm-hmm.
more towards sustainable solutions. And when I was working with Bell Canada, which the pioneers of telecommunications, I was working with Bell, and there I started more towards energy efficient buildings and smart cities with a larger goal of reducing carbon emissions. I was doing those kind of projects, and I worked a bit in carbon in corporate sustainability groups as well. Post that, I studied climate change for a year in University of Toronto, and then I kind of pivoted towards pure climate change solutions. So right now, I'm working with PCS as an advisor and advise on the net zero and carbon reduction strategies for the financial market in Canada, which includes the top banks, insurance companies, pension funds, asset management companies. So these companies, when they decide on the net zero journey, they take certain pathways. So I consult them on what kind of pathways to take, how to decarbonize their portfolios, and all that. Yeah.
Okay. Got it. So, before we move on to your work experience, or we like the audience would love to know more about your technical journey, like how you started it from the beginning, like how your interest towards climate came, or like were you from starting into this climate change, or like what was your motivation for going into this field?
I think my larger motivation was around the social and NGO sector. While I
Mhm.
was working in different companies, for example, I spent close to 9 years, I think, in Infosys, but I was also part of Infosys Foundation, which is an NGO arm of Infosys that funds a lot of projects for social good. So I was part of that. I was doing a lot of social work there. Then I was working with that this was in Pune, that started working with an NGO called Doorstep Schools. I used to volunteer with them on the weekends, and I used to go on plantation drives to green the local hills of Pune. And then when I moved to Cognizant, I became the core committee member of Cognizant Foundation, that again funds a lot of projects on social good. So I had been alongside my technical journey, I had always been associated to this social causes through some way or the other. And I think I was on the lookout for some kind of a change in my career to make it 100% of that factor and less of the corporate journey that I was doing. But prior to that, because you were asking that, I was purely a technologist. I was never a manager kind of a person. I think Kaushal and I go back in purely from the technology side of things. So I worked on different software technologies. In I think 2007, I became a technical architect. From there, I pivoted to solution architecture and then customer-facing enterprise architecture roles. Um, I've always been on the edge of technology. When mobility come, I was in mobile application. Then the cloud come. Then IoT came, and so Internet of Things was very interesting then. And there's a very strong correlation of Internet of Things with sustainability, and I kind of used that to satisfy my craving for working for the larger good of humanity. and I thought this was the right cause. Climate change was the right cause to work on. So that's how I came here, and I'm still marrying. I'm not a pure climate change consultant. While because I'm strategizing and advising to customers, I have that bit. But when it comes to solutions, there are technology solutions that work in the climate change space that I then consult on.
Understood. Understood. So what I also wanted to know that many students are not well aware with this role, because uh, if talking about Indian students, they are more inclined towards the technical role. If you want to go into software developer, Java developer, all these roles are well aware for the Indian students. So, sir, can you put some light on basically what does a climate change and a sustainability consultant does? Like, how does his day look like? Just an overview, or just to make the audience understand.
Right. So now, because you're asking about students who have opted technology in the first place, let's
Hmm.
assume we're talking about those category of students, and not the ones who choose sustainability as a program to start with.
Right.
So supposing they have opted for engineering or some kind of software background, uh, there are a lot of things you can know. Software is just a tool. You can solve financial issues, financial problems like risk mitigation, fraud things, anti-money laundering, any kind of financial risk or capital markets, or travel industry, or whatever, whichever industry you're working with. You can solve those problems, or you can solve climate and sustainability problems. So the
Sure.
domain could be anything, right? The tools, if you have the software tools, uh, you could use it for anywhere. For example, I'm working with a large bank in Canada, and they need climate risk modeling people. So now these climate risk models are inherently built in Python, and there is a Watson ML library that they use. So they're basically using IBM Watson machine learning plus Python experience, that kind of people who are very core into that and can build climate models. These climate models are very specific to they're different. I would say there are 10 different kinds of models you can build. Not the models that can predict how the extreme weather conditions are going to be in the future, not those models, but the effect of those physical models on the GDP, on the economic growth, on the portfolio of the investors, because these banks are, when they take your deposit, they invested in a wide variety of instruments in the market. Now if they invest in, let's say, a commercial property near a sea beach, there's a and with climate change there's a high risk of sea level rise. So you need to calculate the exposure, risk, and vulnerability of those commercial properties. So how do you calculate that? So build models around it to see how that geolocation plus the probability of hazard there plus the vulnerability, how the building is created, all those things go into building some sort of physical climate models. Similarly, there are transition risk models also based on energy prices and all. So what I'm trying to say is, I think I took it a bit more complicated route. What I'm trying to say is technology can be used for anything.
Right.
It is your choice. What do you want to use it for? I'm using it for cleanliness of water as well, which is a pure IoT solution.
Mm-hmm.
Or, for example, in Canada, there's a lot of snow. So, snow removal trucks go from here to there. How do you reduce their fuel usage? How do you give an optimized path for snow removal trucks, which are called snow plows, across the highways or across the roads? What is the most optimum way? So, there minimum fuel use, but the snow is cleared from the roads. So, that kind of solutions come under smart cities. We've built that as well. Uh, so it takes care of the sustainability part because using less fuel, so less emissions, less carbon dioxide in the atmosphere. But it
Right.
is also a purely technical solution.
Right.
So I think once you're starting the journey, you need to focus on what you want to work on, what kind of domain you want to work on. If you
Right.
don't have a plan, then the company you end up with, they will make use just of the technology that you have.
Correct.
If you're interested, for example, Kaushal did this project in Hyderabad, right,
Right.
on the irrigation project, which
Right.
is a great water optimization of water usage. Smart agriculture is something that we are using in prairie provinces of Canada
Mm-hmm.
to help sustainable agriculture, employ sustainable agriculture, and help more carbon dioxide get sequestered in the topsoil. So that takes care. That solution involves satellite imagery, image processing, and everything, and finding the absorbed carbon, the topsoil, which is a great solution. And not many people have it. The TCS has the solution, and it is liked by customers as well. But it is purely built on AWS and Azure kind of cloud platforms, built on Java, Python kind of libraries. So it's sustainability is a domain, and it is the opportunities in sustainability are going to explode like anything.
You're right.
This is the place to be in.
Understood. So one more thing which I which I want you to put more light on, that word which you use was, we have to, like, that there should be reduction of carbon emission, right?
Correct.
So like how is the carbon, first of all, the carbon emission affecting today's climate? And also, sir, what I wanted to ask, that is it also somewhere related to the global warming?
Absolutely, completely. So, I mean, that's the climate science part.
Correct.
The thing is, the average rise in temperature. Let me explain you. When we say, if you read about climate change, you will try to understand that India, US, Canada, Europe, everybody is trying to control the rise in Earth's temperature to 1.5 degrees C and not beyond. That is what the Paris Agreement says, which every country signed in 2015. 1.5 degrees C, what it means is that from 1850s to 2000s, the average deviation from the normal temperature should not be more than that. Across the history of Earth, this anomaly is very less. So what happens is, right now we are in an interglacial period. Last ice age was around, let's say, 23,000 years back. So what happens is there are two ice ages. The difference between the two ice ages is around 23,000 years. So top of last ice age to the bottom of the ice age, which is now the interglacial period, that where the humanity prospers the most, because it's a warm period. So in ice age, it is very difficult to live. The conditions are bad. The agriculture cannot work. So at the top of the ice age and the interglacial period, it is the distance. The time is around 10,000 years. And you'll be surprised to know that temperature difference is just 6 degrees. So across 10,000 years, humanity has crossed 6 degrees of temperature, average temperature, Earth's temperature. But in the last 200 years, since the time we started burning fossil fuels, we have already reached 1.2 degrees C. What it means is, if you compare it, what it means is, across 100 years, let's say, it should have been only 0.06 degrees. 10,000 years, 6 degrees is, across 100 years, it should be just 0.06 degrees. Right. But we are already done 1.2 degrees, which means that we cannot let it go beyond 1.5. Otherwise, there are 8 or 10 tipping points in the Earth. They will start crossing. Once they cross, we lose equilibrium, and the Earth cannot maintain the same warm temperature where everybody grows and prosperity grows. Now, your question was valid. How is it related? See, the way global average temperature is increasing, we are also measuring the ppm of CO2 in the atmosphere, parts per million of this is the atmosphere. So from the time cars were invented in 1840s to, let's say, 2020s, there's a steady rise in CO2 ppm in the atmosphere and the average temperature increase. And how do we know it is because of the burning of fossil fuel? Is because of the specific isotope of carbon dioxide, which is found in the atmosphere, which only comes from burning of fossil fuel. It doesn't naturally occur. So there's a very strong correlation that the warming is, in fact, an increase in carbon dioxide in the atmosphere is causing the warming. So that is why we call it anthropogenic emissions. Now, all the climate models say that if it increases too much, everything will start changing. Like the ice sheets in Arctic and Antarctic are going to melt. Now, you can't imagine there's such huge ice sheets that they reflect most of the sun's rays outside. A lot of it. Now, when they start melting, one is the sea level rise increases, which means cities like Mumbai and Calcutta and all will start disappearing slowly. It also means the water absorbs more heat, which means it expands, so it further rises. So there are very sophisticated models that are already built. They're called global circulation models. They're already built that can say how much would the earth change in 1.5 degrees C change, 2.5, 3.5, 4.5? These are called pathways. Now, when I talk to banks, their portfolios could be in fossil fuel companies. Their portfolios are also in soybean, beef, meat productions that are causing the most deforestation of Amazon rainforest, by the way. Billions of dollars are being pumped even today. So when I talk to them, we talk in terms of decarbonizing their portfolios for different pathways. Supposing Earth heats to 3.5 degrees C, what is the risk that the banks have to bear? So I have to
Right.
calculate those kind of things. I hope I'm able to answer these
Yes,
questions.
sir. So, to be very frank, like I'm listening to you, like literally as if I have to give the examination, because it is so much easy to understand whatever you are saying, and it is so much the way you are explaining. Like I'm really listening to you as if the next half an hour I have to give the examination for that. So
I
it's,
can speak for hours, don't
yeah,
worry.
sir. Yes,
But
sir.
it's not just CO2, by the way. There are six gases: methane, nitrous oxide, sulfur hexafluoride, and hydrocarbons. And there's a lot of science behind it and a lot of policy structure around it as well. Carbon taxes are coming into being, for example. India is becoming so very interesting thing if you want to learn more, and your students if they want to learn more, or if they want to get into this field via the engineering side. TERI is a great institute in Delhi.
Okay.
The environmental research, I think it's called the Energy Research Institute, TERI. I talk to a lot of TERI folks, and we have hired some people from there as well in TCS, specifically for CO2 emissions and everything. But my role is not just climate change, by the way. I also do the sustainability part,
Hmm.
and there is a lot of things in sustainability. Typically, we say it is ESG. ESG is another term that we use: environmental, social governance. So in social, we also talk about human rights. What about if we clean the, let's say, the whole supply chain of a fashion retailer in India? That supply chain may lead to Bangladesh and Vietnam and wherever the textile is being actually made. How do you decarbonize the whole value chain? You just can't remove your carbon emissions, but the clothes that you are wearing or I am wearing, there are probably 60 gallons of water that goes into making one t-shirt that I am wearing right now, that cotton t-shirt. 60 gallons is too much, of fresh water. We cannot waste it. So how do you manage the water resources through the supply chain? So those kind of problems are very interesting to solve. We have to solve it. Somebody has to solve it, right? So I think the kids you're helping or you're advising on career, they have to take the right choices. We cannot. There's a limit to growth. We cannot keep
Right.
on thinking about how to grow more and more money.
Right. Understood. So, so let's say the global warming and everything is there. That is right. So, do you think, while looking at present scenario, that India is somewhere the main culprit for the climate change?
No, absolutely not. In
Okay.
fact, if when you talk about climate justice,
Hmm.
India has just started throwing out carbon in the atmosphere in the last 20-30 years.
So, which is the country, sir, which is affecting the more for the climate?
So yeah, so Europe and the
Okay.
US,
Okay.
they are the maximum ones. Because see, when you're driving your bike or your car,
Mm-hmm.
each molecule of carbon dioxide that you emit
Mm-hmm.
stays in the atmosphere for more than 100 years. It doesn't disappear from the atmosphere. Every single molecule of CO2 goes in the atmosphere, stays in the troposphere for 100 to 400 years, by the way. The current global warming is not because of India. Current global warming is because of the countries that first got industrialized. Europe, US, Canada's, and the UK's. They have thrown such huge amount of carbon dioxide in the atmosphere that intensity is now taking the effect, and it is let. So what happens is, when carbon dioxide stays in the atmosphere, the sun's rays come through it and reaches the earth. But when 50%, generally, if there is no less greenhouse gases, 50% of it goes back to the atmosphere. But because of these gases, the return path is in infrared range. These gases don't let the energy go back to the atmosphere, so they reflect it back, and then this reflection keeps on going, and very little amount goes out of the atmosphere. So the denser the gas is up there, Earth gets warmer and warmer and warmer. And it, because I told you, methane stays for 15-20 years, but certain other gases stays for more time, carbon dioxide stays for 400 years. So currently the warming that we are facing is because of the developed nation. That is why climate justice says these countries now need to pay. By the way, in COP27 that happened this year, the first time the loss and damage function has been instantiated, which means the developed countries now need to pay underdeveloped or developing countries to decarbonize, because it is because of their effect that we are facing it.
Understood.
So the
Understood.
floods in Pakistan, for example, is not because of Pakistan itself. It is because of
Correct.
the emissions that have happened here.
Correct. So whosoever
India is
does,
doing good, by the way, but India is a
yeah.
major player going to be in the future,
Okay.
because it is going through a trajectory of development. But this is the time they need to get into sustainable ways of development.
So we can say whosoever does the damage, but everyone has to suffer the loss.
Everyone has to suffer the loss. Unfortunately, tropical countries bear it more. India,
Correct.
Pakistan, Sri Lanka, Bangladesh, this belt, global circulation model works in such a way that Europe and Canada's and US are going to bear less loss because they're up in the Arctic.
Right.
The rest of the countries around the tropics are going to bear a lot.
Right. Understood. Understood. So coming down, first of all, you have explained very well about the climate change and sustainability and about also the CO2 emissions and everything. So let's say, sir, if you have to give any message to the young people who are looking to go into this field or who are fascinated, or you can say passionate about this field, what would be that message which you would want to give to those students?
I would say, depending on the tool set you have in your bag,
Hmm.
you can use that tools to do anything you want.
Correct.
But choose your problems carefully.
Right.
Life is very short. You cannot solve all the problems. I'm
Right.
not saying don't buy big houses or cars or whatever you want, but understand that there's a difference between true happiness and satisfaction when it comes to your career choice. Don't get into something in which you later on feel it is meaningless.
So I'll come down to my last question. So do you have any message to the students who are aspiring to go into this field or who want to learn more about this field?
Yeah, so what I'll say is, so there could be, as I said in the beginning, there could be two kind of students who have already taken a technology field.
Mm-hmm.
They can certainly work on solutions that are related to sustainability or climate change,
Mm-hmm.
like the ones I mentioned, whether they are decarbonization related or in any other field. It could be finance, it could be energy utilities, or decarbonizing manufacturing. There could be anything. So that's one way. Or the second way is that they go into the consulting or business analysis side of sustainability, which comes into pure strategy and advisory work. So my take is that the tool sets are there. Uh, Generally, the students that come to you and generally the youth in India is they're brilliant. They just need to choose the right kind of problems to solve. We may not need to solve the problems that are repetitive or which have no meaning. It is a good idea to choose the problems that humanity is facing, because sustainability itself means living within the means, within in such a way that you're able to meet your needs without
Absolutely.
compromising the needs of the future generation.
Absolutely.
So yeah, those are the last words.
Thank you so much, sir, that you have shared such a valuable experience and also valuable inputs about the climate. And I'm sure that the students who are aspiring or who wanted to learn about the climate change, about the carbon emission, and also about the global warming, so all these things, I'm sure that it will help students. And I'm glad, sir, that you have joined us today in this podcast. And I would love to have more podcasts like this with you on different topics, sharing your
Sure,
experiences, right, sir? So once
absolutely.
again, thank you so much, sir, for joining us, and
Thank you for having
have
me
a,
here.
yes, have a great day ahead. I know that now you will have a sleep right now. You will take rest. Thank you so much, sir.
Thank
Wish to
you.
meet you
Thanks
soon.
a lot.
Great.
Sure,
It was
absolutely.
nice meeting.
Okay.
Bye, sir. Bye.
Anyway, bye.